You're welcome to New Focus Approach to Mathematics Basic 7, Revised Edition. In this video, we are looking at sample space, another terminology that we need to understand when dealing with probability or chance. But this is a continuation of the basic terminologies under the introduction of probability. Now, what is sample space? Sample space is a set of all possible outcomes of an experiment. All possible outcomes of an experiment. We learned from our previous lesson that experiment simply means any action or operation that the outcome is not certain. Okay, so for example, we are about playing a football match. We don't know the outcome, so that becomes an experiment. But what are the possible outcomes that will happen when we end a football match? Those outcomes are what we refer to as the sample space. So for sample space for a football match between two teams, the outcome can either be a win, a lose, or a draw. So these are the possible outcomes. Every match that ends, it ends with either a win, a lose, or a draw. There's nothing like in between, unless the match didn't end. Okay, but when the match ends, we have win, lose, or draw. So that becomes a sample space. So here our sample space, the number of sample space, which we normally use S to represent sample space, become 3. You get it? Good. Now, what if you toss a coin once? You toss a coin once. If you toss a coin once, the sample space become either head or tail. Either head or tail. Anytime you toss a coin, we have two options, either head or tail. So our sample space is head or tail. The number of it becomes only 2, right? What if the coins are 2 and you're tossing them once? Or you have only one coin and you're tossing it twice. What will be the outcome? If you toss 2 coins once or tossing a coin twice, the possible outcome will be either head appear or heads appear in both coins, or one will turn head, the other will turn tail, or one will turn tail and the other head. That means if the first is head, second is tail, or first is tail, second is head, or both appear tail. So here the sample space for the outcome or the possible outcome that we can see from throwing 2 coins is this. And here the number of sample space become 4, because either this or this or this or this will be the outcome. What if the coins are 3 and we toss all of them once, or we have just a coin and we do the experiment 3 times? We toss first, we toss second, we toss third, or we throw first, second, third. What are the possible outcomes? When we are done with the 3, either the first appear or either all of them will appear head. Do you get it? All the 3 coins will appear head, or the first will appear head, second will appear head, third will appear tail, or first will come as head, second will come as tail, third will come as head, or head tail, or tail, or tail head, or tail head tail. Okay, or finally we can get tail head. So these are the possible outcomes if you toss 3 coins. Either you get all of them appearing tail, or first one will come as tail, the last will come as head. Now the number of sample space here becomes 8. Okay, becomes 8. So these are what we call the sample space. We can use this to solve series of questions. We'll do that in our next video. In general, take note of this. In general, tossing a coin or coins, the sample space is given as this. It's so beautiful. So what it means is that where ends the number of coins or number of times we toss. So what it means is that if I toss a coin 5 times, then my sample space is going to be 5 to the power 2 to the power 5, which will give me 32. That means sample space will be 32. If I toss only 3 coins, I'm going to get 2 to the power 3, and that will give me 8. So sample space will come as 8 possible outcomes. Number 5 means 32 possible outcomes, right? Then what if I'm throwing a die? If I throw a die once, okay, if I throw a die once, then the possible outcome will be either 1, 2, 3, 4, 5, or 6. Okay, the normal die that we use to play Ludo has only 6 faces, and the 6 faces, the numbers are 1, 2, 3, 4, 5, 6. So these are the possible outcomes. It means that when you throw this die, any of these numbers can appear. That is the sample space. And here our n, our number of sample space is 6. You get it? Good. Then what if I give you 2 dice, to throw them once? 2 dice to throw them once. What would be the outcome? For example, here we say throwing a die twice, or throwing 2 dice once. So I have die A and die B. If I throw them once, either all of them will appear as 4-4, or all of them appear as maybe 3-3, or one will come as 3, the other one will come as maybe 2. I mean, it depends. They can come in different format, like one coming 5, the other one coming 4. So can we generalize all of them? We can tabulate this like this. Maybe die 1, die 2. So either my first die comes as 1, second comes as 1 as well, or first comes as 1, second comes as 2, or first can come as 1, second 3, or first can come as 1, 4, 1, 5, 1, 6. Or I can also say the possible outcome can also be that first die come as 2, second will come as 1. First will come as 2, second will come as 2. I mean in that order. So we can fill this and get all the sample space that can possibly come out. And the possible outcome becomes number of sample space becomes 36, because it's going to be 6 times 6, 36. So these are the possible outcomes. So in general, we are also saying here that throwing a die, the number of sample space is given as 6 to the power n. So if your die is only 1, you're going to get 1 to the power 1, which will give you 6. If there are 2 dice involved, we'll get 36. If there are 3 dice involved, then you see that the outcome will be very, very huge. That is going to be 216 will be the sample space. So that is general. So here our n represents the number of times we throw a die, or the number of dice that are thrown once. With this, we come to the end of this video. Watch out for the next video. Thanks so much for watching.